A farmer discovered his horse was extraordinarily intelligent. You could ask it an arithmetic problem, and it would tap out the answer with a hoof. Researchers were fascinated and tested the horse. They discovered the horse understood algebra, Euclidean geometry, calculus, and even group theory. However, when they gave the horse problems with Cartesian coordinates to graph, it just stood there dumbly like any horse. This was quite surprising, given how intelligent the horse was otherwise. They brought in an expert who examined the situation and explained the problem. Of course, the horse cannot understand any Cartesian coordinates you show it. You are putting Descartes before the horse. And maybe my older people will get that one. Descartes, by the way, came up with the Cartesian plane. And there's an old saying, never to put the cart in front of the horse. Too much explanation. All right, but let's go ahead. So this is our introduction to our linear regression unit. And basically, yes, I know I look very upset there. We are trying to figure out how many rubber bands Barbie needs to have a thrilling yet safe jump from the balcony in our sea wing. The height of the balcony is 541 centimeters, but that's my Wonder Woman Barbie there, by the way. And here's the catch. You only get to use 7 rubber bands to figure this out. So what are you going to do? Well, I'll just show you what we did in class. We basically took a rubber band and we created a first rubber band around the ankles, all right? So, and then we measured how tall Barbie is upside down so that we would put that height in. So when we had 0 rubber bands, this is how far down Barbie's head was. And the reason is, why are we measuring the top here? Well, if we're going to do the bungee jump, you get disqualified if you give Barbie a concussion. So we want to see how far the very top of her head goes, all right? And if she already doesn't have a rubber band around the ankles, go ahead and make one. And then we attach a rubber band and then we drop it and we measure how far her head travels. Then we do 2 rubber bands and 3 rubber bands, and it gets more interesting the more rubber bands that you do. And since she will be bouncing, it helps if you use slow-mo to record it. So we are going to record the data from 0 to 7. Now, what variables should we record to create our rubber band bungee cord? The number of rubber bands used and the distance traveled, or you could say the lowest point for her head. So are these categorical or quantitative? Well, they both involve numbers, and it's not like rank, but actual measurements. So we're going to say quantitative. Explanatory variables are the variables used to predict the input. These are also known as the independent variables, like X. Response variables record the outcomes of your study or your output. So that's like your Y. So which one of these should be like our X, explanatory, and which one should be like the Y? Well, we would say the number of rubber bands is explanatory because it explains how far Barbie's going to travel, which is our response. So we use Scatterplot. There are many different ways to create a scatter plot. This is just one. I'll show you a couple more in this lesson. And you can see here what you're going to do is you can use Scatterplot and type in the data, and I'll show you. So if you go there, you can just put in your explanatory and your response. So here we have number of rubber bands, and then type in your data with a space or a comma between them. So I went from 0 to 7, and then type in what your response variable, in this case, the distance. And I typed in the distances. This is just from another group. And you just, again, I'm putting a space. Make sure you have one number so that you have pairs of numbers, coordinates. Then begin analysis, and voila, you have a scatter plot. All right, so you should, if you're doing notes, sketch that scatter plot onto your notes. All right, so how would we describe the relationship? So I'm going to use the scatter plot I had on the previous slide. Yours might be different if you gather data. And there are a couple different things we want to talk about when we describe scatter plots. One is direction. One is unusual features, form, and strength. Now, if you're a fan of The Simpsons, you might notice there's an acronym here, DUFFS, Duff's, one of Homer Simpson's favorite beverages. So anyways, we explain direction by saying if the dots are increasing or decreasing, or pretty much staying constant. And some of my notes, I forgot to have a nice pattern like that, so you might need to add that in. So it could be that there's not really an increase or a decrease. There's no relationship. You can also describe this as having a positive, a negative, or zero or no association. So this example, in this case, because it's increasing, and we always say from left to right, we say this is a positive association. So you should go ahead and write that on the graph that's higher up on the notes. All right, how about unusual features? Are there any outliers, anything that looks really unusual? And in this case, there are not. And we'll have some unusual features later in some examples. The form, it's either going to be linear, nonlinear, or no real forms. Oh, I forgot to say, make sure you make a note there's no unusual features on your thing. All right, so we have linear, nonlinear. So there's a pattern in a nonlinear. It's just not a straight line, and no form. Strength, we're basically going to say it's either, so our form for this is linear, and then our strength, we're going to say it's either strong or weak. This is an example of strong, this is weak, and we can see that our pattern definitely looks strong. So if you're using ClassPad to create your scatter plot, first of all, you can click on Start a New Sheet once you get there and click on Data, which is that icon. Enter your data in 2 columns. X values, or what we call the explanatory variables, need to be in column A. So ClassPad's a little picky that way. And Y values should be in column B. Highlight both columns. So you're going to click on the A and the B, and you get this window, which is the statistics window. We have been using calculation, but today we want to use graph right there. Once you click on graph, then it's going to say, well, what type of graph do you want? Well, today we're doing the scatter plot, which is right there. Once you click on that, then you get a beautiful little graph right here. Now, the TI-84 is usually faster for entering data. A lot of my students prefer it. So enter your X values in list 1. You can use a different list, but if you do, remember which one you're using. And Y values we typically do in list 2. Now, if we're going to graph it, once I've entered the data, like we've done before, press second stat plot and choose plot 1. And make sure that is turned on. So see how that's on right there. Then select the first icon, this one right here, and that's your scatter plot. X list, well, that should be list your values of X values, and typically list 1. And then select your list of Y values, typically list 2. Although if you're doing residuals later, it can change. And then press graph to see the scatter plot. So there's the graph button right there. You may need to press zoom and then scroll to 9 zoom stat to see it, because a lot of times it's scaled different to what you have your data.